All right, today we're gonna be doing Algebra 2, Chapter 9.1, Special Angle Triangles. We're gonna start by talking about the 45, 45, 90 triangle. So I've got a 45 degree, 45 degree, 90 degree triangle on the board already. One of the identities with triangles is if these two angles are the same, then the side that correlates to those angles are also the same. So the opposite of 45 degrees, this length, and the opposite of this 45, this length, these two legs are going to be equal to each other. For that reason, I'm just going to give this length of x and this length of x, all right? So now, we're going to come up with an identity that we can use all the time using Pythagorean's theorem. So Pythagorean's theorem says that side a squared plus side b squared equals the hypotenuse squared. In this case, my a is equal to x and my b is also equal to x. So I'm going to get x squared plus x squared equals the hypotenuse squared. So now when I go to solve to identify what is this hypotenuse length going to be, I'm going to get x squared plus x squared is 2x squared equals c squared. And I'm trying to solve for c, so I got to take the square root of this side. And whenever I do this side, algebra tells me I have to do this side. So I get the square root of 2x squared is equal to c. All right. I'm not quite done. The last chapter that we did, we learned how to rationalize denominators. We learned how to deal with radicals as well. And I know I can't leave the square root of 2x squared like it is because while the 2 is stuck under that radical, the x squared is a perfect square in itself. So we know that the square root of 2x squared is the same thing as the square root of 2 times the square root of x squared, and that's just going to be x. So I'm going to move it out front as x square roots of 2. So my hypotenuse here is going to be x square roots of 2. And we kind of want to memorize that because that's going to help us on all the ones going forward. So when you have a special case triangle, and it won't always tell you that these are 45 and 45 degrees. If it just gives you a triangle, and it tells you that these angles are equal to each other by having one hash mark through each of them and it's a right triangle, the only possible way for these two triangles to be equal to each other is for them to be 45 degrees apiece, because I know that the sum of the interior angles has to add up to 90, or to 180. This one is 90, so these two together have to be 90 and they're the same. So that would mean that these have to be 45 degrees. All right, so don't just look at it as when it tells you that 45 degrees they are. If they tell you that the same and it's a right triangle, then they have to be. All right, so we know that anytime we have a 45, 45, 90, that these two legs are the same, and the hypotenuse is going to be x squared root of 2. So if we put that into practice, let's move this up a little bit. We'll make this another triangle beside it. We're going to make it a right triangle, and we're going to say that these angles are equal to each other. That way, immediately we know this is a 45, 45, 90 triangle. It has to be. All right, so in the examples, it may give you, it'll tell you that this leg is equal to 12. And it wants you to determine the length of the unknown sides in each triangle. So you have to identify what this side is and what this side is. Despite, when I drew this triangle, this side visually is shorter than this side, but my back drawing is overruled by the fact these angles are equal, so this has to be the same. So if this one is 12, that one is also 12. And now we need to figure out what the hypotenuse is. Well, if I go back to this original one and I say this is x and this is x, and my hypotenuse is x square root of 12, then I can recognize all I need to do to find the hypotenuse is replace this x with what I said this is equal to. All right, so I'm going to get 12 square roots of 2 over here. All right, I did not have to do a lot of math to get to that. If I memorize this identity, and that's why we solved it using Pythagorean's theorem, is we can use it every single time now. We don't have to just use it, or don't have to use Pythagorean's theorem on each individual triangle. This is the formula that works. All right, maybe it gives us to it a little bit different. We'll just use that same triangle. Go ahead and get this written down. That way you have it in your notes. Let's look at the same thing, but maybe this time, instead of giving us a leg length, we still know it's an isosceles triangle, right? These two sides are the same because these two angles are the same. So we do know that it is an isosceles triangle, which means, in this case, it's a 45, 45, 90. Let's just say maybe it gives us the hypotenuse length this time. If it tells us that the hypotenuse is equal to 12 units long, now it wants us to find the 2 leg lengths. All right? So if I know that the hypotenuse is x square root of 2, so I'm going to just make some notes over here. The hypotenuse is equal to x square root of 2, which in this case is equal to 12. I know the legs are equal to x. So I'm going to take this part right here, x square root of 2 equals 12, and I'm going to solve for x. I need to isolate this variable. How do I move the square root of 2 over here where it wants being done? The operator is multiplication, right? I'm multiplying x times the square root of 2. In order to move it from this side to that side, I need to divide both sides by the square root of 2. So those cancel out, leaving me with x is equal to 12 over the square root of 2. I would love to be able to leave it like that, but in the last chapter we learned you can't have a radical in the denominator. We have to rationalize it. So as many times as I've said throughout your time with me that algebra builds off of itself, and something that we did for an entire chapter that we are just now about to taking the test over, now it's just a small part of this problem. I just have to include it in what I'm doing. So how do I rationalize the denominator? I have to multiply by that radical. So I need to multiply by the square root of 2. Whenever I do the bottom, I have to do the top. On the top, I get 12 square roots of 2. On the bottom, I get the square root of 2 times the square root of 2, which is just 2. And I can't leave it like that because the 12 on the outside of the radical and the 2 in the bottom can reduce. I get 6 square roots of 2. All right? So if h equals 12, and h also equals x square root of 2, now that I solve for x, I'm going to replace x over here. This side has to be 6 square roots of 2, and this side also has to be 6 square roots of 2. So we just had to use Pythagorean's theorem on those to make sure that we solve for one it didn't give us. In the first case that we had on the board a minute ago, it gave us a leg length, and we had to use that to find the hypotenuse. This time it gave us the hypotenuse, and we had to find the leg lengths. All right, so we did that from this identity with a 45, 45, 90 triangle. All right, so now we're going to bounce over here to the other side, and we've got a 30, 60, 90 triangle. And right now it doesn't look like that. Right now it looks like a 60, 60, 60 triangle. It's equal angular, so all the angles are equal. But if I was to, let's see, if I draw an altitude, all right, so if I go right down the middle and draw an altitude, essentially what I've done there is I broke it into 2 90-degree triangles. If this is 90, that would be a straight angle, that would also be 90. So these 2 triangles are going to be exactly the same. We already said that this one was a 60-degree angle. Now we have a 90-degree angle. This one was 60, but it's split right in half, so now this is a 30-degree angle, this is a 30-degree angle, and it's going to mark them as the same. This one is 60, this one is also 60. All right, so now we're going to focus on one side of this. We've got the altitude drawn right up the middle. We've split it into a 30, 60, 90 triangle on that side, and a 30, 60, 90 triangle on this side. All right, so I've got 60 and I've got 30 degrees. We're going to say that this is side X with an equal angular triangle. It was equal angular. And it was also equilateral. Alright, so that means all three angles were the same before I split it in half, and all the sides were the same. They were all the same length. So they were X, X, and X. So this one is still, let's see, how do I want to do this? Let's call this one, let's go with the short side. This is X, and because it's half of one it originally was, that means it was originally twice as long. So if this is X and this is X, that means this would be X plus X, which is 2X. Alright, so again, I'm just focusing on one, but I want you to see how I'm breaking these sides down. So I've got X and 2X, and then I've got the height over here. Alright, so now this triangle, X is a leg, H is a leg, and then 2X is my hypotenuse. So if I want to find out what the last side is, I'm going to have, we'll just call it H. We're going to go with H squared. That's one side. I'm doing Pythagorean theorem, but I'm doing it as it's labeled. H squared plus X squared equals the hypotenuse squared. I've got to make sure I put that in parentheses because I'm squaring that whole side, not just the X. Alright, so H is going to be, I'm going to solve for H. I want to get that length. So I need this, so I'll simplify that side. I got H squared plus X squared equals 2X squared is 4X squared. I need to subtract this X squared from both sides so it cancels out, and I get H squared equals 3X squared. Then I take the square root, that and square root cancel, I get H is equal to, again, just like a minute ago, 3X squared. X squared is a perfect square, so it's going to come out as an X. And I'm going to get X square roots of 3. So the height here is going to be X square roots of 3. Alright. So just like a minute ago, with anytime it's a 30, 60, 90 triangle, I'm going to be able to use this identity. So if I make a 30, 60 triangle, say, I'll make a small one that's easier to deal with. So, let's say 30 degrees is right there. And I want it to be 90 degrees. So I need to make sure I match everything up. Alright, so I've got a 30, 60, 90 triangle. What I know about every single one of them is that this side length is X, the other leg is X square roots of 3, just like we said here, and the hypotenuse is going to be 2X. That's the case of every single 30, 60, 90. The X is going to be opposite the 30-degree angle, X square roots of 3 is going to be opposite the 60-degree angle, 2X is always going to be my hypotenuse. So if it gives me one and it tells me that, let's say that the short leg, X, is 12. I don't want to do this, we'll say 12. Now it wants me to find my long leg and my hypotenuse. So I've got short leg is equal to 12. I know my long leg if I replace x with 12 here, we'll say that that still equals x, just so we see that original identity. If I replace x with 12 here, then I need to replace x with 12 here. And my hypotenuse, I need to replace that x with 12, so I get 2 times 12. So I get 24. Alright. So I know that I get my short leg is just 12, my long leg is 12 square roots of 3, and my hypotenuse is 2 times 12, which is 24. So the nice part about it, again, you're going to have to solve a lot of triangles that are not special case triangles, that are not 30, 60, 90. 9.1, all of them will be. So with this homework, with this classwork, and on this portion of the test, it'll tell you to solve the 45, 45, 90 triangle. You know you'll be able to use this identity. It'll tell you to solve the 30, 60, 90 triangle. You know you'll be able to use this identity, and once you've got some practice with them, it won't seem as weird as what it does right now looking at them. But down the road, it's going to give us triangles that are not 30, 60, 90 anymore, and we're going to have to use Pythagorean's theorem and do some other things to solve every single one of them that will require more work. So definitely start on this homework as soon as possible. Don't wait a couple days and start on it when you let it slip. You want to get to where you identify those 30, 60, 90 triangles really easily, even if they don't tell you it's 30, 60, 90, but they give you enough information to get there. So that's 9.1. Just get some practice on it. When we come back, we'll work on 9.2, angles on the Cartesian plane.